For elite law firms and wealth managers, adopting the latest AI models has become a competitive necessity. Processing thousands of discovery documents or analyzing complex market shifts in seconds is the new baseline for staying relevant. But standard commercial AI platforms are built on a public cloud model. Using them requires data egress, the constant movement of your sensitive information to third-party servers for processing, which leaves a trail of metadata and telemetry leaks. In highly regulated fields, this data movement is a liability. It risks compromising the absolute confidentiality of attorney-client privilege or HIPAA-protected medical records by placing them within a shared multi-tenant environment. The traditional alternative is an air-gapped system, but these are notoriously difficult to maintain. They require massive upfront capital, limit the ability to update models, and leave firms with hardware that cannot keep up with modern compute requirements. This creates a failing binary choice. Fiduciaries can either accept the exposure of public cloud tools or settle for the restricted capabilities of isolated private hardware. Standard software-defined security is designed to manage data in motion, but it cannot fix the fundamental flaw of cloud AI, the requirement that data must leave the premises. To break the deadlock, the security model has to shift from code-based firewalls to physical boundaries. HecTec AI developed their Trinary Bound architecture to act as a bridge between these two extremes. It is designed to host powerful models locally while maintaining the security of an isolated environment. By integrating hardware that lacks a cloud connection pathway with local AI orchestration, firms can finally use advanced reasoning tools without their data ever touching an external network. The foundation of the system is the Whitestone protocol. It models digital information as physical states of matter, ensuring data only exists in specific forms as it moves through the system. First is steam, volatile encrypted packets moving outside the boundary. Entering the bridge, it becomes water, undergoing hardware sanitization to scrub active metadata. Finally, it commits to the stone state, saved into a physically isolated vault, while volatile memory buffers are permanently destroyed. Mapping data to these three phases ensures that the most sensitive parts of a firm's intellectual property stay locked behind an undeniable physical boundary. The hardware itself is housed in the Arc Citadel, a deployment chassis designed as a physical Faraday cage to block incoming and outgoing electronic signals. The engineering specifications include a Lexan viewport laminated with a copper micromesh. This allows the hardware to remain visible for maintenance, while providing up to 60 decibels of total radio frequency attenuation. Internally, the architecture uses a stateless compute core. It runs exclusively in RAM and is physically incapable of writing a persistent hash or indexing files to the internal storage of the node itself. All traffic moves over a high-speed hardware bus that routes tasks across separate, isolated physical drives, keeping threat scanning, AI orchestration, and the permanent database on completely different pieces of silicon. This design effectively replaces the empty promises of software developers with the unyielding physical parameters of the hardware itself. Within this isolated environment, a group of trinary agents manages semantic workflows locally. These agents organize and retrieve data without ever pinging a cloud server for instructions. This physical isolation neutralizes common remote attack vectors like SIM swapping or browser fingerprinting, which hackers use to bypass traditional login credentials. To access the vault, the architecture requires proof of presence. A user must have the physical token and provide a physical touch, verifying a human is at the terminal to complete the cryptographic handshake. Because the handshake requires a tactile action at the machine, it is mathematically impossible for a remote adversary to compromise the system from another location. For many firms, the actual cost of innovation is hidden in compliance. Third-party cloud auditing retainers and complex data handling reports can drain significant resources every year. This is the SEC building. Under Rule 17a-4, wealth managers face strict requirements for tamper-proof electronic record-keeping. By keeping an immutable local record on an isolated node, firms can establish the specific, non-erasable storage pathways that federal regulators look for. Similar physical boundary controls are a key part of frameworks like NIST and CIS. Maintaining this level of isolation helps firms establish the burden of proof, often required to qualify for tort safe harbor protections under state laws. Sovereignware effectively shifts data compliance from a recurring liability into a built-in feature of the infrastructure itself. This architecture also enables new ways of working. As shown by the spatial headset, an executive can use the secure hardware to step into a private, immersive environment, reviewing thousands of pages of discovery in a three-dimensional space. Using private tunnels, these spatial interfaces allow for the review of sensitive case files with complete privacy, shielding the user's workspace from the public trackers built into most commercial headsets. This model respects the boundary between a firm and its technology providers. It rejects the standard practice of harvesting and analyzing corporate data for the provider's own profit. To gain the full benefits of high-performance reasoning models, an organization needs absolute control over its environment. By removing the need for a public cloud, enterprises can finally bring their data home.